So the next important model is number of factors in a given number. So how to find the number of factors, or what are the factors for a given number? One thing is prime factorization. So prime factorization of 2450 will go like this. Okay, we will start with 2. 1, 2, 2, 5. And it is ending with 5, so I am going with 5. And next one is 5 again. 5 4 20, 5 9 45. Now we are going with 7. Now we have to convert, we have to write everything in terms of multiples of prime numbers. 2 power 1, 5 square and 7 square, right? But this is the longest method possible. Okay, then what is the shortest method? Whenever you find any number, first observe the given digits. When the last digit is 0, that means it is divisible by 10, isn't it? When it is divisible by 10, there is a 1 5 1 2 for sure. So with this 0, I can say that there is 1 5 and 1 2. Now I have to factorize only 245, but for my luck, it is already saying that 5 is already there in that. So I'll go with 5 only. So it is 5 4 20 and 5 9 45, and this is 7 square. Now there is already 5 here, so I can write it as 2 5 square into 7 square. Yeah, the answers are same, but the process could be very fast in this method. Okay, now sum and number of all factors. First of all, let's see the number of factors in a given number. Let me rub this one so that it will be clear to you all guys. So let me write again this prime factorization method. So it is 2 into 5 square into 7 square. Now how many factors are there in this? Can I say 3? No, because you are saying that, sir, there are other exponents also. So now can I say it as 5? Even that is a wrong option. So how to find number of factors here? See the exponents here. Exponents are 1, 2 and 2 for the given prime numbers. Now I will add 1 to this exponent, again 1 to this exponent, again 1 to this exponent. Let's multiply them. So it's 2 into 3 into 3. How much it is? 18. So there are total 18 factors available for 2450. And why I'm adding 1 here? You can comment in the comment box, but let me say that also. I am taking in combination of every prime number. The combination starts from 2 power 0, 5 power 0 and 7 power 0. What is this combination? It is 1 itself. I mean 2 power 0 into 5 power 0 into 7 power 0, it is 1. So 1 is a factor of 2450, isn't it? 1 is factor for every number. That means it is improper factor although. So we can call 1 as a factor. Now what are the other options available for the given factors? 2 power 1 into 5 power 0 into 7 power 0. Can I say 2 as a given, as a factor of 2450 for a given number? Yes, it is also there. Now can I take in combination of 2 with other numbers? Exactly. That means 2 power 1 into 5 power 1. Can that be a factor of 2450? Yes, exactly. 10 is also a factor for 2450. Like that I can take combination. So at max I can consider 2 as 2 power 0 and 2 power 1. That means 2 combinations. 2 ways. In 2 ways I can consider this 2 power 1. In that way I can take this 5 square as 5 power 0, 5 power 1 and 5 square. Total 3 factors, 3 ways. Like that, how many ways are there for me? It is 2 into 3 into 3. So it is a permutation combinations principle. So we are applying it here. So 3 into 3, 9, 9 into 2, 18. So 18 ways or 18 total factors are possible for 2450. Now let's see even number of factors. So for even factors, that means my factors has to be even number. My factors will be even number only when they are a multiple of 2. That means I will not consider 2 power 0 because it doesn't ensure that the remaining factors will be even number. At least my number, it has to have 2 power 1 in that. Now, from now onwards, like 5 power 0 into 7 power 0, it can be even number, right? Yes. Now, keeping 2 power 1 as constant, I can change, I can vary any number of factors here. So, what are all the given are 5 square and 7 square? We should not forget this one because these are the things which are given in the number. So 2 power 1 into 5 square into 7 square is the given number, 2450. So I can have three ways to represent 5 power 5 square. So 5 power 1 5 square and 7 power 0 as 7 power 1 and 7 square. Okay. So in this way I have 9 factors which are even. Okay. So there are 9 even factors. Now 18 minus 9 for the remaining odd factors. Isn't it? Is that the simple one? Yes. But let us see the sum of factors. Sum of factors is nothing but we have to add every factor starting from 2 power 0 plus 2 power 1 and remaining factors. What are the 5 square? So 5 square starting from 5 power 0, 5 power 1, 5 square, like that. But if you clearly observe, is it not in GP, geometric progression? You can add these simple terms, it's not a problem at all. Okay, for some you can add everything, 2 power 0 plus 2 power 1, it's very easy. But these ones, these are also easy. But what if I have a factor of 5 power 28? In that case, it will be very tough. So there we can use geometric progression series, sum of GP series. Okay, that means I can say this as 2 square minus 1 by 2 minus 1. I'm playing this one, a power a into r power n minus 1 by r minus 1. Here r is greater than 1. That's why I am using this. So how many terms are there? 2 terms. So 2 power 2 minus 1 by 2 minus 1 r minus 1. What is the first term? It is a. That means 2 power 0. So 1 into 2 power n minus 1 by 2 minus 1. So that's the thing here. So we will apply this geometric sum of geometric series and we will get the answer here. So these are very easy. So sum and the number of odd factors, sum and number of even factors, sum and number of all factors, it is very easy. But sometimes, like that in the indoor case, they will ask how many perfect squares are possible. That means in my given factorized form, I should have a multiple of, exponent should be a multiple of 2. Then only it will become a perfect square. Why? I can express any square. For example, 81. I can express this as 9 square or 3 power 4. So anything, exponent anything in terms of 2 multiple, I can say that it is a perfect square. You can check that also. For example, 7 square into 5 square. Is this a perfect square? Yes, it is. Even though if you cannot calculate it, if you calculate that, it will be a perfect square only. Because the exponents are multiples of 2. Okay, it is 35 square. Right? Like that. You can express anything powers of multiple of 2's. That means it is a perfect square. Now 2450. Can I express? Can I say how many perfect squares are possible with 245 factors of 2450? Yes, it is 2 power 1 into 5 square into 7 square. Right? Now, can I convert? I mean, can I say any number or can I get any perfect square with only 1 2? No. So I am removing this. Now, how many perfect squares are possible with this? Only 1. And how many perfect squares are possible with this? Another 1. Okay, like that. I can write it as 5 square into 7 power 0. And the same way, 5 square into 7 square. Another one is 5 power 0 into 7 power 0. Isn't it? So, sorry, not 7 power 0. It is 7 square. And yes, obviously 5 power 0 into 7 power 0. How many perfect square are there now? 4 perfect squares. So how to find them? You will consider this as one number and this as one number. And as I said in the previous one, how many number of factors are there? You will consider that each one as one different way. And I can take 5 square as 5 power 0 or else 5 power 2. Like that, 2 ways are possible for each number. So 2 into 2, 4 ways are there. So 4 perfect squares are possible with the prime factors or factors of 2, 4, 5, 0. Isn't it? Okay. If you have understood this one, it's okay. If not, let me explain it another problem. Let me take this one. So 1200. If you express 1200 as in the prime factorization method, we can easily say how many 5s are there in this. There are 2 5s. And obviously 2 2s are also there, but with this 12 also I'll get another 2 2s. So 2 power 4 into 3 into 5 square, isn't it? So let me write it clearly. 2 power 4 into 3 into 5 square is a prime factorized form of 1200. Now, how many perfect squares are possible here? I can express 2 power 4 as in terms of 2 multiples. I mean explained as 2 multiples as 2 power 0, 2 square and 2 power 4. So 3 ways are there. I will not consider 3. Even though if I consider, I have to consider 3, I have to consider as 3 power 0. There is only one way. So 1 into anything is the same thing. So I am not considering this. Okay, now 5 square. 5 square can be taken as 5 power 0 or 5 power 2. 2 ways. So in how many ways I can get perfect squares? It is 3 into this 2. So it is total 6 ways I can get perfect squares from the given prime factorization form of 1200. That means only 6 perfect squares are possible. If you can say, if I remove 3 from this, if you can clearly see, if I remove 3 from this, it is saying that I'll get a perfect square, isn't it? Let us see. If I remove 3, divide this by 3, I'll get 400. Is it not 400 as a perfect square? Yes, exactly. And next, if I remove 5 square also, that means 25. So how much is this? 4 into 4, 16. So like this, we will get perfect squares from the given factorized form. Okay, I hope you got this one. So in the next model, on the same model, different things are possible. Yeah, this is another type in this model. In this problem, find the sum and the number of factors of 1200 such that the factors are divisible by 15. So remember, you are finding the factors which are divisible by 15. Remember that you have to take it from 1200 only. So solve this problem and comment your answers in the comment box. And even in this, find the highest power of 7 which divides 81 factorial. Now we are going to discuss this model in the next lecture. Thank you guys.